All right, we're going to go ahead and get started. Today we'll be running through lab 3, the Analyze and Network Packets lab. Our goals for today are going to be for you after this lecture to be able to capture packets with tcpdump. That's our command line utility for capturing packets. If we want to capture packets, we don't really work. We can just use tcpdump to run in the background on a system and collect those packets for us. Remember, Wireshark is really a read-only application. In Wireshark, we're going to be looking at a TCP dump file, but we're not going to be changing anything. So since it's just a viewer, it doesn't actually write packets, we don't need Wireshark on a machine to be able to capture network traffic. So the first thing we want to do for the lab is to log into the CLI Linux box. Again, remember our username is always going to be root, and the password is going to be root spelled backwards. So tcpdump is a command line utility, so we're going to have to open up a terminal window for that. Once we get into the terminal window, we're going to type tcpdump. We're going to go ahead and enter that command. And what that command will do is it'll start recording everything that's coming out of our network card. I believe that the S is to identify which interface we want to record. And then the tcpdump.pcap is the file that it's going to save it to. We'll go ahead and hit enter. Notice it says it's listening on the interface called Ethernet 0. We're going to leave that terminal window open, and we're going to create some network traffic. Actually, what we want to do is right-click the terminal and say new window. That's going to give us another CLI terminal window. And what we'll do from there is we're going to go ahead and generate some traffic with the Nmap network scanner. We type Nmap and then the address of the computer we want to scan. -5 means I'm going to be scanning the first 5 IP addresses. Hit enter. It's starting to scan the computers on the network. The computers that it is scanning is 192.168.1.1 through 192.168.1.5. It's going to take about 2 or 3 minutes to complete. Okay, our scan is done. So what we'll do now is we'll go ahead and stop the capture. To stop our capture, we're going to hit the control button, control key, and the C key. That'll finish capturing and finish writing our file out to the hard drive so that we can take a look at it. Next thing we're going to do is actually look at the PCAP file. We don't have to have Wireshark to do that. We can use one of the utilities that comes with tcpdump It's called tcpic. What we're going to do is go ahead and open that utility. Okay. So what it did is I took our capture file. It took our capture file and it read out the entire capture so that it is in a format that we can understand as a human. And what it did is it dumped it out to our screen. What we can do now is scroll through the output of that command. Notice that it has color coded our fields and put them together so we can actually see what was going on in the capture file. You can see which device is sending traffic and what type of packet is being delivered. So we can see this is the source IP, source port. This is the destination IP and the destination port. Here's the type of packet that was sent, a reset packet. So this is actually a three-way handshake. Usually we have a SYN, SYN-ACK, and then an ACK. When you look at it in tcpic, it is going to be displayed as SYN sent, SYN received, and then established. So it's just using different terms, but that's the three-way handshake between the two computers. What you'll notice as you scroll through here is you have a number of these three-way handshakes, and they're on different ports. Every time I have a three-way handshake, it goes to a different port. Looks like it's incrementing by 2 every time, the source port. 56, 58. Seeing that in a capture from tcpdump kind of alerts us that there's one computer that is sending three-way handshakes or TCP connection packets on different ports to the same computer. That is an indication of being port scanned. Since we have one computer and it's opening up multiple connections to my server, like I said, that is an indicator that we're being port scanned. Another thing that you may want to keep in mind is um, a lot of these attacks, these port scans like this, don't finish the three-way handshake. They're not interested in actually sending data to the computer. They just want to see if the data's port, the computer's port is open so that it can start looking for vulnerabilities in the system. So you might see SYN sent, SYN received, and then no connection established. So keep that in mind too. So that's how we would do it from the command line interface, analyze some network traffic. We can also do it through a GUI interface that's easier to use, and that interface is called Wireshark. It's under our menu, under Group 9, Sniffing, and then Wireshark. When you load Wireshark, it's going to give you an error message. It's going to tell us that we are running Wireshark as a super user, and that just to let us know that. We're going to hit OK. Because this lab isn't actually connected to the internet, we don't want you attacking computers on the internet from our NetLab pods. We notice there's a lot of activity on the network adapter right now. That is because the computer is desperately trying to get out to the internet. Um, it is sending ARP requests out and trying to look for other computers and for default gateways to try to get out to the internet. But it's not going to be able to because we have you isolated in this lab. Because it's doing that in the background, it generates a lot of white noise with our capture. So what we're going to do is we're going to apply a filter, a save filter. And what it's going to do is it's going to hide the ARP packets. And it's also going to hide the DNS packets. So we're looking for no ARP and no DNS. Here we go. We're going to click there. And then we're going to start our capture by clicking the fin, the shark fin. Notice it put our filter up there already, so we're not seeing all of that traffic that's being generated from the computer trying to get out to the internet. Next thing we're going to do to generate some traffic is go to the terminal window again. And we are going to ping another computer. So we'll say ping -C8 192.168.1.2. The -C option tells the ping utility how many packets you would like to send. So we're going to send 8 packets. Normally we just run ping and then we hit Control-C to break out of it. We're going to specify 8 packets this time. Go back to our Wireshark window. We will see these pings that we just sent. Notice they're in pink. Notice the source and destination of each packet. Our computer to the computer that we specified in the command to ping. We specified computer number 1.2. So that is the request, and then we get a reply back from 1.2. Back to our terminal window. We'll generate some more traffic with Nmap. So we're actually going to perform a port scan on the network for computers 1.1 to 1.5. F is a fast scan. Again, this may take about 3 minutes to complete. Our scan is done, and now we can go to the Wireshark window and see our port scanned. So notice we see the same information that we saw on the other display from doing TCP dump. We're seeing a connection from one computer to another. Send packet and then a reset packet. So this type of scan is not waiting for the connection to finish. It is just sending the send packet. If it gets a reset, that means that the port is not open on the destination machine. So we know the machine is on, it's just that the port is not open on that machine. Remember, this high volume of traffic to various ports is going to be an indicator that this is a port scan or reconnaissance taking place. In order to get a better picture of what Nmap actually does, we're going to flip over to the Windows machine. We're going to have to do a Control-Alt-Delete. Remember, the password is capital password 123. We're going to open the Toolbox folder. We're going to double-click Wireshark. Again, we don't want to have all the extra traffic from the computer looking for internet connection. So we're going to turn on our filter again. No ARP, no DNS. We're going to start our capture. Notice the interface is exactly the same whether I'm in Linux or I'm in Windows. One thing that we missed is we forgot to switch the interface. So let's go ahead and do that now. Remember, we want to make sure that we captured on the Ethernet interface. So once we have the Ethernet interface highlighted, we hit Start. I'm going to jump back on the CLI machine and do a port scan. Back to our terminal window. We're going to do a different type of scan. I believe this is a stealth scan. Our scan is done. We're going to go ahead and switch back to the Windows machine. Notice we can see our scan that was performed on this machine. Notice there's a lot of send requests. Send packet, send packet, send packet. The client machine is responding back with a reset. That's what it'll look like on a Windows box. We're going to go ahead and stop our capture. If we're doing any kind of work with security, most of the time we're going to want to save what we observed. In order to do that in Wireshark, what we're going to do is hit Save As, and we're going to give it a name, Wireshark. Then we'd be able to bring up that capture later on so that we could come back to it if we needed to show someone else what we observed. We can also do that save on the CLI machine in the same way. So we're going to stop our capture on the CLI machine and we'll save it. We can also open up saved captures that we created before. For example, we can open up this file here called Dictionary Attack. Since we are using the same Wireshark window and didn't close the Wireshark window, we need to remember to remove this filter. To do that, we just click the X here. So we don't have that filter on there anymore. We see a lot of this yellow SMB traffic. That indicates somebody trying to log into a Windows box. Scroll over it a little bit more. We can look through these packets and notice that the person is trying to log in as an admin account. There is the admin account again. Notice these authentication requests are coming from the same computer over and over and over. That should be suspicious because we know that it's not normal traffic. It's not people from different computers trying to log into the Windows box. It is a person from the same computer trying to log into the Windows box over and over and over again. So we can scroll through here and see all of these messages. Another file we can open up on the NetLab workstation is called Telnet Raw. In this particular capture, we can see a lot of Telnet traffic. Remember, Telnet is not encrypted, so we would actually be able to go through here and retrieve this file that's in this stream, it looks like. We have a lot of Telnet data going back and forth. Remember, Telnet is for sending commands to a remote system. Notice when I put the stream together, I can actually see what was going on in this Telnet session. Notice they logged in as a user called fake, and the password was user. They logged in, and we can actually see their session. That's why it's important we don't use Telnet when we use our networking tools, because somebody can capture our traffic on the network and actually see it. It's not encrypted. You can go through some more of these files and testing types of attacks. But again, Wireshark will allow you to do that. And the more you use Wireshark, the easier it'll become for you to navigate through these capture files. So Wireshark is definitely a tool you'd want to know as a security analyst to be able to go through captures to find out what had occurred on the network. When you're finished with that, that is the end of the lab. You can log out of your CLI workstation and then end your reservation.